The light and motor application. There's an old person phrase, can you walk and chew gum at the same time? It means, can you do two simple things at once? We want to build robots that are exciting, big creatures that show off and do our bidding. Let's look at our design first, then dig into the code. We created indicator lights to help us see what is going on in the code. The blue light turns on 1 second after the code begins and stays on forever. The green light turns on during the direction control function. The yellow light turns on during speed control. White during the stop function. You can really spruce this up. These lights could be turning on to the beat of a song you play. They can be timed to look like water geysers. It's really up to you. The lights can be part of another function, or you could write your own light function that makes your crew happy. The idea is for you to think about what can you do to spread joy through your design. We added some strings to this wheel because it made us laugh. It made the tire look like a Muppet. You can push this design much further with gearing and other accessories. Just keep exploring. For the code, we used the basic structure of previous codes. We just pulled them together in a new way. Now we have motor 1 operating with ENA in pin 3 and the in pins at 4 and 5. We still have our lights connected to pins 10 through 13. We could even add a second motor if we wanted in pins 7 through 9. You have that code as well. The setup operates the same. Make each pin we use an output. Set their values to low using digital write. Our loop looks pretty simple because the functions are doing most of the heavy lifting. We call the delay function built into Arduino for 1 second. We turn the blue light on by writing blue to high. Remember that blue doesn't mean just blue, it means pin 13. This code says we're turning pin 13 to high. That's how we talk to the Arduino. Then we call direction control, where we embedded some new code to turn on the green LED. Then we take a break for another second. We use our yellow function to turn the yellow light on for 0.2 of a second. Then we start the speed control function and turn the yellow light on for the whole time we are in this function. Similarly, we call white as a function. And then we have the white light turn on during the whole time stop runs. So let's break this down in the functions. We won't look at the delay function because that's built into Arduino. So is digital write. Those two lines are code. They do things. Our first function is to direction control. Now we can see in direction control that I can tell a pin called green to turn on first. Then it runs through the normal program, full speed turning one way. Motor switches full speed the other way. After that, the function is completed. The last line tells the green light to turn off by writing the output pin to low. The next function is from the LED video called yellow. It just turns on the pin, waits for 0.2 seconds, then turns off the pin. The next function is speed control. First, the yellow light turns on. Second, the motors accelerate. Then the motors decelerate. Finally, the motors turn off and our yellow light turns off. Same idea in the white and stop function. The white code has 3 lines. Digital write on, delay 200 milliseconds, digital write the pin to off. In the stop code, we have the same digital write the white pin on at the beginning and off at the end. However, in the middle, we ensure that the motors are off and the code is delayed 20 seconds. These code examples are hardware design, use lights, strings, and wheels, and they're intended to really spark your imagination. What can you design with these tools that no one has thought of? What could your code do that would make people you care about smile? How could the robots make your friend laugh? Start putting these tools to good use. Thanks for learning with us.